In this video, I'm going to show you how to use the prop.test function to perform a right-tailed test about a single population proportion. The way you do this is you need a set of hypotheses first. In this particular case, I have two hypotheses. One is that p equals 0.2, and the other one is that my alternative, that's p is greater than 0.2. That greater than is telling me that I'm doing a right-tailed test. Now, to perform this test, I need to decide upon a probability for a type 1 error. So I'll call that alpha, and I'll decide I want to use 0.03 there. And then based upon that, I'm going to make up a rule for rejecting my null hypothesis. And the rule I'm going to have is going to look very similar. It's going to be I'm going to reject my null hypothesis if p, or my p-value, is smaller than my significance level, that alpha. And then I'm going to say to myself, well, in the real world, I'd have to go out and collect a sample, and I'd want it to be a simple random sample. So we're just going to have to pretend that the data I've collected here is a simple random sample. And then I'd also need to determine that I've met the other assumption for this test, that I have a big enough sample size. Now, to have a big enough sample size, I have to have my n times my p0 value being bigger than 10, and n times 1 minus my p0 value being bigger than 10. Now, in this particular case, p0 is that 0.2. So my sample size here is 200. I have 0.2, and 200 times 0.2 is about 40. N times p0 is 40, and that is bigger than 10. And also 200, which is my n, times 0.8, which is 1 minus p0, that is also bigger than 10. So I've met both the assumptions to run this test, so I know in the end that I will have approximately the right significance level, approximately the right probability for a type 1 error there. Now, how do I go about getting my test results? Well, I'm going to pull out the prop.test function, and I'm going to type in the number of successes I have here, which in this particular case we said was 41. Then I have to type in my sample size. Sample size here was 200. Then I have to say what my p0 value was. That's my hypothesized value. So that's going to be p equaling, in this case it's 0.2. And then I have to say what type of an alternative I'm using. And the alternative in this case has got a greater than in it. So I'm going to write in greater. And then I will leave the rest of the options to their default. This will give us a slightly different result than what we would have gotten from the procedure in class, but it's close enough that we won't worry about it. And I'll run this. And if I look down at my results here, what I really care about is this line here, which tells me what my alternative is. I care about this line right here that tells me that I've got the right null hypothesis being used. And then I'm going to look at this, at my p-value, and I'm going to ask, is that smaller than my significance level, smaller than that alpha value here? In this particular case, it is not. So this would be a case where I would fail to reject my null hypothesis. There's nothing more we can get out of this one because these are just sort of made up numbers, so we can see how the calculation works. But there'd be more of an interpretation if we had some real data here. But that's how you can go about using prop.test to perform a right-tailed test for a single proportion.